Welcome you all. In this video we are going to solve one problem on mechanical translation system. This is the problem statement given to us. Determine the transfer function y2 of s divided by f of s of the system shown in figure. And while seeing the system we can see two masses are there called m1 and m2. This is the mechanical translation system because this is having mass as a main element, and there is one applied force is there f of t which is applied on mass m1, and there will be a separate spring and dashpot are connected with the mass m1, and there will be a spring that is connecting both m1 and m2, and this is the given system. While uh, in the problem statement itself they have told that y2 of s divided by f of s is required. So this is the transfer function equation. So by observing this equation we can say that output for the system is y2 of s and input for the system is f of s. So that we draw the that we solve the problem by drawing free body diagram. There are two free body diagrams are there. So first free body diagram based on mass 1 we are drawing. So this is mass 1, and in this particular node there is one separate input force f of t, and then f m1, f k1, f b1. These are all the uh, opposing forces. Okay, so there will be an opposing force due to m1, k1, b1, and there will be an opposing force due to this k2 also. Okay, and this is the opposing forces acting on that body, and this is an opposing force given by the spring k2. Okay, I'm giving some special color to this k2 because this is double end element. This is connected between m1 and m2, so we need to use the separate formula for this term. And now this is the first step in our problem, and we need to create the differential equation. We need to write the differential equation by means of applying Newton's law of motion. So sum of applied forces is equal to sum of opposing forces. So in this particular node we are having applied forces f of t and opposing forces such as fm1, fk1, fb and fk2, and and this is the equation. The differential equations. We need to substitute the value of fm, fk, fb in this equation. We will get this equation. Fm means m1 into d square y1 by dt square. See, in this problem itself the displacement at mass 1 is mentioned as y1, so we need to use the same notation over here. So m1 into d square y1 by dt square plus k1 y1 plus b dy1 by dt. These three terms are especially dedicatedly connected with only the mass 1. So use this formula, and then if k2, the k2 spring is nothing but connected in between mass 1 and mass 2, so we need to take the difference of that displacement. Okay, and also I am referring with respect to the mass 1, I am writing the opposing force. So k2 into y1 minus y2, this is the exact value of the opposing force given by the k2 with respect to mass 1. Okay, let's rearrange the equation. You simply bring all the y1 terms in front, and then you are writing the y2 terms. This is the first differential equation. Okay, we are rearranging the terms again, and this is the equation number 1, which is first differential equation. This is done by means of drawing the free body diagram based on m1. And now let's take the Laplace transform. Okay, while taking the Laplace transform, it is very simple that f of t will be f of s, and y1 will be capital Y1 of s. The differential term d square by dt square will be s square, d by dt will be s. So this is what the equation after the Laplace transform taken, we are representing as it is 2, equation number 2. And then we are moving to the free body diagram on based on mass 2. You can see that mass 2 is only connected with the spring, that is the spring which is connecting both m1 and m2, and there is no applied forces on that body. So in this particular node there will be two opposing forces called fm2 and fk2. fm2 is due to the mass 2 itself. fk2 is nothing but the spring that is connecting m1 and m2, which is producing the opposing force like fk2. Okay, we are we are now supposed to write the Newton's second law of motion. I mean, 0 equal to, there are 0 applied forces here, so 0 equal to Fm2 plus Fk2, and let's substitute all the values of Fm2 and Fk2. So you can see now this is the Fk2 value we are writing with respect to the mass 2. Okay, so we are writing the value as K2 into Y2 minus Y1. This is the very important thing while writing the formula, I mean the expression for double end element. So now we are rearranging and it is marked as equation number 3. This is also the second differential equation. Okay, this is the two node systems, I mean two masses are available, so two differential equation is there. So these differential equations are available in our solution. I mean equation number 1 and equation number 3 will be the two differential equations of the given system. Now we are taking the Laplace transform of the given system. This is the Laplace transform, and what we need is we need y2 of s divided by y f of s, is it not? So kindly go through this second equation. The second equation is having y2 of s term and f of s term, is it not? So what we need to do is we need to remove the term y1 of s. Actually we need y2 of s and f of s. While rearranging this term, we will get that equation called y2 of s divided by f of s. That is the transfer function we can obtain. But the problem is the unwanted term y1 of is there, y1 of s is there. So we need to remove that term. How to remove the term y1 of s? It is possible by means of replacing the value of y1 of s by means of some other expressions. Okay. So this can be obtained by the equation number 4. You can easily bring the value of y1 of s like this: y1 of s is equal to m2s square plus k2 into y2 of s divided by k2. You can see that this y1 of s is now available with us in terms of y2 of s. Let's substitute this y1 of s value in equation number 2. We are getting this expression. From this expression itself, you can bring the y2 of s as common. This is the obtained equation. We can bring the y2 of s on left side. This is the resultant equation, but what we need is y2 of s divided by f of s. That is the actual value of transfer function. So what we need to do is we need to reciprocate this equation, and we will get this equation. This is the y2 of s divided by f of s. I mean this is the transfer function of the given system, that is k2 divided by m1 s square plus k1 k2 plus bs into m2 s square plus k2 minus k2 square. This is the transfer function of the given system. I mean we are given with one mechanical translation system. We did it by means of taking free body diagram, writing differential equation, taking Laplace transform, and rearranging the Laplace transform. Rearranging the Laplacian transformations. We are supposed to determine the transfer function value. So this is the final value of the transfer function. Thank you.